I'm sure some of you were probably worried and thinking, how come you did multiplication and division and not do addition and subtraction? Well, I decided to do addition and subtraction last because it is a little bit more complicated to do. But don't you worry, I'm not going to jip you out of that because I know how much you like addition and subtraction. When you want to add or subtract, you need to find a common denominator and then just add the numerators or subtract them and keep the denominators the same. Sometimes you'll already have a common denominator, and that's a good thing. Sometimes you won't have a common denominator, and you won't even be able to get a common denominator without factoring, because what you're trying to factor, or because what you're trying to find a common denominator for, is just not simple. Now, for the first problem, the denominators are the same, so I just keep the denominator, and then I combine the numerators. So I have 2x plus x is 3x. I'm combining like terms. And 3 plus 18 is 21. All right, now, just like when you added fractions, when you get done, sometimes you may have to reduce. So let's factor the top and bottom and see if we have to reduce. I factor out a 3 from the top, and the bottom is our old friend, the difference between two squares. So I factor that. The x plus 7's cancel, and I get 3 over x minus 7 left. And as far as my domain goes, if you're interested, and I know you are, the domain can't be plus or minus 7. So x not equal plus or minus 7. We say what the domain isn't, basically. Now you might be saying, well, how come it can't be negative 7 if you crossed it out? Well, for the domain, even if you cross it out, it doesn't matter. You still have to avoid that value. Okay, let's do another problem now. How about if we do 2 over x minus 3 over x plus 1. Now, a lot of times people will look at a problem like this, and actually let me use a different color here because that way it'll kind of stand out from the other problem a little bit. No, maybe I'll use a different color. Whoa! Okay, don't do that. Come on now, don't be mean here. Okay, nope. Okay. All right, I'm having an argument with my thing. I'm losing. Okay, no, I don't want all those. Well, that's okay. We'll just leave it. It's going to be the same color. A lot of people, when they do this, they see this x and this x plus 1, and they think, oh, I just have to add a 1 to this denominator. Everything will be okay. Well, when you're creating a common denominator, you're not allowed to add. You can only multiply. No adding allowed when creating a common denominator. So my common denominator is actually, I have to multiply each denominator by the other. So I'm going to multiply this fraction by x plus 1 on the top and bottom. And I'm going to multiply the other fraction by x on the top and bottom. Okay? Has to be done. You can't just add 1 there. It'd be nice, but would also be incorrect. So now I use the distributive property here, and I get 2x plus 2 over x times x plus 1. Now notice I didn't multiply out the denominator because that's just not as important. I have to multiply out the numerator because if I don't multiply out the numerator, I can't combine the numerators. But the denominator just stays the same, so it doesn't matter if it's factored or not. Okay, so I rewrite this denominator. I put the x in front in both. It's just personal preference. And then if you have several things up here, you would go boom, boom, and then however many things there are, you'd have to change all the signs. Well, I only had one thing, so that's good. 2x plus negative 3x is negative x. 2 has nothing to combine with. And on the bottom, I have x times x plus 1. And looks like nothing can be simplified. Definitely don't want to try to cancel those because this x is connected to a 2 by love. And then as far as the domain goes, looks like x can't be 0, and x also can't be negative 1. Okay, I think the last problem I'll do for you as far as addition subtraction goes, let's do something like this. How about x plus 2 over x squared minus 9, and then minus x plus 1 over x plus 3. Now, some people might look at these denominators and say, man, those are so different. I have to multiply each one by the other like I did up here. Actually, though, you don't. If you factor first, you can see that they're not as different as you think. So they look very different, but they're not as different as you think. It's kind of like a life lesson. Sometimes people look different, but really, we're not all as different as you think. We're all similar. You know, we all have the same things going on, right? I don't know. That's like a little philosophy for you. But anyhow, x squared minus 9 is x plus 3 times x minus 3, difference between two squares. And now you can see that really the only thing missing from this second fraction is an x minus 3. They weren't so different after all. You thought they were really different, but they really weren't that different at all. So I multiplied top and bottom by x minus 3. Now, you're going to be really excited about this because when you multiply the top by x plus 3, because it's already a binomial with two terms, our old friend FOIL is going to come into play. So that's good. You know, you can make a FOIL man if you want. So let's go ahead and multiply this out so we can combine it. I'm not going to multiply the denominators because they don't get combined. They just stay the way they are. So I have x plus 3 times x minus 3. If you want to write them as x squared minus 9, again, you can do that. It's up to you. Here I have x plus 3 times x minus 3. And then the x plus 2 didn't change. But here I FOIL this, and when you FOIL it, you get x squared minus 3x plus 1x is minus 2x. And then 1 minus 3, or 1 times negative 3 is negative 3. And now I'm just going to combine like terms. And to do that, I make this sign positive, and I go boom, boom, boom. And I get x plus 2x. I'm going to get a 3x. I have, so the x's are gone. I have a 2 and a 3. That's going to give me 5. And I'm putting these in order. This is what's called standard form when I go from the highest power to the lowest. The order doesn't matter for addition. And then negative x squared, I'll put that out in front. Plus 3x there, plus 5. On the bottom, x plus 3 times x minus 3. Now, you might want to see if the top can be factored and combined with the bottom. I will just tell you from my experience, it's not going to happen for this problem. But you can try it if you want, but I don't think so.